All right, at this point, I can't even keep track of what page we're on, but number 26, here we go. This one says a triangle has side lengths 28 inches, 4 inches, and 31 inches. Use the converse Pythagorean theorem to show if the triangle is acute, obtuse, or a right triangle. So, remember that the Pythagorean theorem says that if it's a right triangle, then the leg squared plus the leg squared will equal the hypotenuse squared. Now, we talked about that's not always the case when you're creating just any triangle, right? You've got 3 lengths and they can create all different kinds of triangles. It could be a right triangle or obtuse or an acute triangle. So the converse just says, well, let's test it to see if it is a right triangle. So we take the short length, which in this case, one of the short lengths would be 28 inches, and we square it and we add it to 4 squared. If it is a right triangle, then those 2 must be the legs because they're the shortest. Then we compare that to the long side squared, and we see if it's going to be equal to or greater than or less than. So if we go through this and we look at 28 squared and we add that to 4 squared, we should end up with 800. Now if we square 31, that is 961. So notice that these 2 sides combined don't even get me to where this one's at all on its own. That means that there's a really long side on this triangle, and that means that this must be an obtuse triangle because that side's really long. So then we would say that this would be an obtuse triangle. Remember, if it's equal, those would be a right triangle. Number 27, we're back to some set notation. So if we're looking at this one, we're given a Venn diagram once again, and we're just asked to define the elements of which the set that would belong, given the indication here. So remember, again, this one means or. I'm going to go through this pretty quickly. Again, biology or Spanish means that they can be taking biology or Spanish, and they get to belong. So we would include all of those students, and I'm not going to list them out, but again, it would be all of them, Bob and Steph and Alex and Julia and Andy and Mark, all the way up through here. Or is very inclusive. All of them would belong. Part B means that they are not taking calculus. So remember that symbol right there means not. So if they're not in calculus, then we're looking at all students right here, but they can't go into the calculus circle. So we're not going to include any of those ones, but all of these students right here, and we would list them. And I guess maybe I should show you again. Remember when we list these, we use the little braces, and then we talk about who's not taking it. So for example, Patrick is not. Ashley is not. Mark is not. Matt is not. And then moving down, Andy is not. And Julia is not. And all of those elements or individuals are not taking calculus. Looking at the next one, this one says Spanish and calculus and biology. The only kid that's taken all of them is good old Bob there in the middle. Part D says calculus and biology. So again, calculus and biology, Molly and Bob are both taking those. So they're both involved. Again, it doesn't say anything about the others. And then lastly, E says calculus or biology or Spanish. Now, if you're looking at or, remember that's very inclusive. So they could be taking calculus. Oh, I apologize. It's saying not calculus or not biology or not Spanish. So everyone that is not in calculus would be these guys over here. So they could belong to the group. Everyone that's not in biology are these guys over here, so they could belong. And not Spanish would be these guys, which means Bob is the only one left out of this set. So we would create those set braces and we would list every name except for Bob. On number 28, I am going to go through this one, even though it appears that I did not give you a triangle. It says for the following triangle, and there's no triangle here, so let's draw one in. I apologize. Looking at a triangle here, let's say that we have side 25 as our hypotenuse and maybe 24 here, and we want to determine the side that is not given, so let's find x over here. Again, it asks us to determine the side. Whenever we have 2 sides, we use the Pythagorean theorem. So we say, well, leg squared plus leg squared is equal to hypotenuse squared. And I forgot to square both of those, so that's effective. So looking at that, if we do 24 squared, that gives us 576. And 25 squared gives us 625. We subtract the 576 over to isolate the variable, and that leaves us with 49, which is a nice number because when we square root both sides, the square root of 49 means that x is equal to a nice 7. Part B then asks you to find, or state rather, whether the lengths form a Pythagorean triple. Now remember, a Pythagorean triple, these are any 3 positive integers, or in other words, 3 whole numbers. For some reason, definitions like to say positive integers, which means there can't be any radicals or fractional values. They have to be integer values, and they create a right triangle, or in other words, when you do the a squared plus b squared, it always equals that c squared. So in this case, it looks like we have 7 and 24 and 25 as our values. So those 3 are all positive integers, right? There's no fractions, so that would be a Pythagorean triple. So part A, we would say, is 7. Part B, I'm sorry, this is so messy, then we would say yes, they form a Pythagorean triple. I'm going to skip over 29. Again, 29 is related to one I did on a previous page with a 30, 60, 90 triangle, or you can always use sine or cosine or tangent to work through those. Okay, just make sure again that you can find one piece at a time, and make sure that you're labeling them correctly related to that. Number 30 says solve the quadratic equation. Remember, this one is in vertex form. We can tell because of this piece that's raised to the second power. There is only one x in here, so that's going to be really easy to get by itself. We just have to undo everything to solve for this x. So we need to get rid of the 1 first, then we'll get rid of the 2. Remember, you cannot multiply the 2 inside of here while it's being squared. So the 2 we're going to divide out before we ever try and do anything with it. So we're going to subtract this 1 to start out with. And we have 2 left here on this side, and then we have negative 20 on this side. Again, we're going to get rid of the 2. It's being multiplied, so we're going to divide it. We end up with x plus 7 squared, and negative 20 divided by 2 is negative 10. Now notice the squared piece is the next part to undo. It's on the outside of our function here. So we want to square root, because the opposite of squaring is square rooting, so that undoes that, and we square root this side. That leaves an x plus 7 over here. We can write the parentheses or not, because there's really nothing, there's not a power there that needs to be related to those parentheses. And then remember, we always use this plus or minus sign when we square root 2 sides of an equation. The only reason we don't within our trigonometry is because the values represent lengths, and so we use the positive solution there. Also, there's a negative inside of here, so remember that comes out as an I, and then we leave 10 in there. Now, if we could break down 10, we would, but it only breaks down to 2 and 5 as its factors, and there are no groups there. Our last step here then would be to subtract the 7 over so that the x is by itself. So our final answer here with x by itself would be negative 7. We generally write that numerical value in front, plus or minus I square root of 10. This would be our solution here. Number 31 is related to dilation. So we recently spent a lot of time with these. This says that 2 polygons are similar, so it tells us up front. And it tells us that EFD, so this first one, has been dilated to create the second one. So right off, before I even do anything, I'm going to draw a little arrow so I remember which direction it's going. And notice it's getting bigger. So when I find my scale factor, that scale factor needs to be a value greater than 1. If it's not, I need to check. So the first thing we're going to do is find the scale factor of dilation. Remember to do that. So for part A, the scale factor we take one side of the dilated image and just divide it by what it was originally. So if I'm going to take 16 right here, it corresponds over here to 12. So I'm going to take 16 and I'm going to divide it by 12. Again, generally we're going to simplify that, and this one comes out as a crazy decimal, so instead I'm going to leave it as a fraction. Not a crazy decimal, it's very clean, but goes on for a while. So 4/3, we'll leave it at that. And notice that value is greater than 1, so that is an enlargement. That makes sense. The figure should be getting bigger. Again, if you find yourself putting 3/4 and it's upside down, then we just went the wrong direction with that. The last part then asks you to find the value of x. Again, you guys are really good with this. You just need to set up a proportion. So like 16 is to 12 as 12 is to x. Oh, that's wrong. Don't do that. Yikes. As 20, because it's in the same spot as x. There we go. So 16 is to 12 as 20 is to x. I need you guys in class to correct my mistakes here. All right, so then we multiply those together. We get 240 on that diagonal, and we get 16x there. So then we divide by the 16. And when we do that, we end up getting x is equal to 15. Now again, some of you guys like to use the scale factor to find it instead of proportions. That's fine too. All right, another page down.